Hi kids. So we are going to finish up these worksheets. We went up to the very last bit of question 3 the other day in class, so let's finish that. So we need to find out what is the perpendicular distance from the focus to the tangent. Now the tangent has been proven as x minus 2y minus 1 equals to 0. And the focus has coordinates 0a, which is 2 in this case. So the perpendicular distance formula states this. So absolute value of 1 times 0 plus negative 2 times 2 minus 1. Square it off. 1 square plus root 2 square. Therefore, now the top here is negative 4 minus 4, 1, so it's negative 5, and the bottom is root 5. That is 5 over root 5, which is root 5 units. So that is the perpendicular distance from the focus to the tangent. Okay, now part B. We're going to use a similar method what we did in part A to prove that, to find out the value of A such that it is a tangent. Just a reminder what we did in part A, we substitute x equals 4t and y equals 2t squared into this equation before. And then we do the same thing here, but instead of finding the value of t in this case, we need to find the value of A such that it is a tangent. So therefore we solve x plus y plus A equals 0 and x equals to 2t, y equals to t squared simultaneously. In other words, 2t plus t squared plus A equals 0. Now, this is an equation about t. Let's tidy this up a little bit. If you find the value of t such that it becomes a tangent, that is basically the parameter for the point of contact. Remember, t is the parameter. So for this line to be a tangent to the parabola in here, there's only one intersection between this line and the parabola. Again, one intersection implies there's only one solution for this new simultaneous equation. One solution for this new simultaneous equation implies discriminant equals to 0. First of all, we need to find the discriminant, which is b squared minus 4ac. That is 4 minus 4a. So for the line to be a tangent, discriminant equals to 0. So therefore 4 minus 4a equals 0. Of course, a equals to 1. So that is how we do this one. The value of a is 1 when it becomes a tangent. Now, I will do question 4 right here. Now, to start question 4, again, you know I really would like you to test you a billion times in this case. Now, x squared equals to 16y. Well, 4a equals to 16. A equals to 4. 2ap, ap squared. 2a is 8. ap squared. Okay, so just make sure you remember that. Now, so once you put it in, now find the equation of the normal of that. Now, remember we have derived it before. Just a reminder for question 4. The gradient of the tangent is always the parameter itself. So gradient of the tangent is always going to be p in this case because it is 2ap, ap squared. So in other words, the gradient of the normal, that is negative 1 on p. Now, you can put the p and the a into the normal formula and just quote it, but I prefer to actually work it out myself. 4p squared equals to negative 1 on p, x minus 8p. Py minus 4p cubed equals to negative x plus 8p. Therefore, we have x plus py equals to 8p plus 4p cubed. Remember, the formula was x plus py equals to 2ap plus ap cubed. Of course, it's satisfied when a equals to 4, which we just derived. So therefore, that is the equation of the tangent to this parabola at the variable point P. Now, given that the normal or the normals passes through the point 0 and 44. Now, this is a very similar question like what we got before. We did it in class. Show that there are 3 points on the parabola have such normal, and we also need to find their coordinates. All we need to do for part B, now the normal passes through the point the point 0, 44. Again, there's only one way we can deal with this. We just subbed it in. So therefore, we sub x equals to 0, y equals to 44 into the normal equation. That will give us 0 plus 44y, apologize, p equals to AP plus 4p cubed. Let's move everything to the one side and solve this properly. We can divide it by 4. So it's 4p cubed minus 36p equals to 0. Divided by 2, 4. P cubed minus 9p equals to 0. P out, p minus 3, p plus 3 equals to 0. Therefore, there are 3 solutions, p equals to 0, or p equals to 3, or p equals to negative 3. And each of them will correspond to a point on the parabola, which will give you the normal that passes through 0, 44. As usual, the first one when p equals 0, which is the one vertical, the vertical normal, and when p equals 0 is in fact the origin. So this is where the point when p equals to 0. And when p equals to 3, first of all, when p equals to 0, your point p equals to 0, 0. Easy. 2ap, ap squared. It's done. So if you sub it in, when p equals to 3, your capital P is ap, 24, 4p squared. 4 times 9, 36. So 24, 36, somewhere around here. And that would have a normal that passes through 0, 44. And of course, we have a very, very similar one on the other side when p equals to negative 3. P equals to, again, AP, negative 24. And if you sub it in, you still get 36. So therefore, that's another point. Negative 24 and 36. Very similar to the one we got before in class. And this is the third normal when p equals to 0, which of course, a vertical normal always passes through any point on the y-axis. Okay, question 5 is a little bit more challenging. So P and Q are points on the parabola where parameters P and Q. Of course, you should have state. Let's write it down. We need to find out question 5. So P is 2AP and AP squared. Q is 2AQ and AQ squared. In this case, we don't know the values or we don't know the value of A, so it is just in the general form. State the equation of the tangents at P and Q, and hence we need to find out the intersection of R of the tangent. So, if you have your formula sheets ready, or if you remember that, the tangent at P is y equals to px minus ap squared. I don't have a formula sheet, but I do remember them. Tangent at q is y equals to qx minus aq squared. Now, find out the intersection of the two tangents. We need to solve them simultaneously. Solve them simultaneously. Give you px minus ap squared equals to qx minus aq squared. Px minus qx equals to ap squared minus aq squared. Take our common factor x, p minus q, a in here, p plus q, p minus q. The x coordinates of the intersection is the y, which is a brackets p plus q. And then sub x equals to a brackets p plus q into the equation of the tangent. Either one will work. I'll just get at p. That is y equals to px, x is this one, a brackets p plus q minus ap squared. That gives you ap squared plus apq minus ap squared, which is apq. Therefore, r is a brackets p plus q brackets apq. So that is the equation of, that is the intersection of the two tangents. Now, part B, we need to find out the intersections of the normal, but we need to state the normal first. So normal, again, you don't need to remember this. At P, it's x plus py equals to 2ap plus apq. Similarly, normal at q would be x plus qy equals 2aq plus aq cubed. If I call this equation 1 equation 2, now to solve normal is a little bit more tedious, but quite actually. I need to solve them simultaneously. Just 1 minus 2 to get rid of the x. Finding y is easier. So we got y brackets p minus q equals to, let's take the 2a out. So it basically is 2a brackets p minus q, a out, p cube minus a q cube. Oops. And you would be able to factorize the other one. Well, in case someone will ask me, 2a p minus q minus a brackets p minus q p square plus pq plus pq square. That's a difference of 2 cube. And cancel, cancel, cancel. Y equals to 2a minus a brackets p square plus pq plus q square. Okay. All right. So, but that is the y coordinates of the intersection of the two normal. The x coordinate, you can sub this back into one of them, but I don't like doing that. I just want to solve simultaneous equation. So I just multiply the first one by q minus the second one multiplied by p. So therefore, I got qx minus px, and this two term will cancel. That's the whole point. Equals to 2apq minus 2apq, which is ap cube minus a pq cube. Please don't ask me how to get that. You'll find it out yourself. Q minus p. Take out ap cube. And then we got p square minus q square. Difference of 2 square. Therefore, x equals to negative ap cube p plus q. So therefore, what is the intersection of normal for the question stated as u? So u is negative ap cube p plus q, and then y is